In this video, we're going to discuss how to find the local maximums and local minimums, also known as the relative maximums and minimums of a function and its graph. So a function f has a local maximum at C if there is an open interval I containing C, so that for all x values not equal to C in I, said interval, f of x is less than f of c, and we call f of c a local maximum or local max of f. Now, again, that probably sounded like a lot of gibberish to you because formal definitions can kind of be hard to work with. However, what I want you to see from this is that if we choose an x value, I'm sorry, a c value in this interval so that it has the highest output of any other x value in that interval, then what we have is a local maximum. Another way of thinking about it is it would be a mountain peak. Because if we come over here and look at our graph, you'll notice that right here, this point is a mountain peak, or what looks like a mountain peak, because its y value is higher than any of the other y values around it. And that's what's meant by a local or relative maximum. On the flip side of that, a function f has a local or relative minimum at C if there is an open interval I containing C, so that for all x not equal to C, f of x is actually greater than f of c. And in that case, we call f of c a local minimum of f. So just like the local maximums looked like mountain peaks, we can think of local minimums as valleys, because just like a local maximum, we want the y value to be higher than any other y values around it. With a local minimum, we want the y value to be lower than any of the other y values around it. So an example here would be this point where it looks like it's in the valley between two mountains. So as far as the working definitions go, the easiest way for me to determine where we have local minimums and local maximums would be to look for the valleys and the peaks within the graph. If it's not a valley or it's not a peak, then we don't have a local maximum or minimum. Now, there's a key to keeping up with some terminology when working with local maximums and minimums, and that is that the x value always tells where the local max or min occurs, and the y value actually gives us the local maxima or minima. So let's look at this example here, and let's start with part A. We want to determine at what number or numbers, if any, does f have a local maximum. I'm going to go ahead and scroll this on down and get it out of our way. So remember, local maximums look like mountain peaks. So I come over here, the only place on here that looks like a mountain peak would be right here. And now notice it's not higher than this over here, but that doesn't matter because remember, we're just picking an interval. So the interval that we choose can be a small interval. For example, we could just be looking at the interval from here to here. And if we're just looking at this area right here, then it's easy to see that that is the highest point in that interval. And that's the reason that we refer to it as a local maximum and not an absolute maximum for the entire function. So at what number does it have a local maximum? Well, remember the at is defined or given by the x value. So if we come over here to our point, it has an x value of 2. So the local maximum occurs at 2. And what is the local maxima? Well, the maxima itself is given by the y value, which in this case is 0. So we have a local maxima of 0 at 2. That might be how we would say it. What about the minimums? Well, remember that minimums are given by basically valleys. So we have two in this case. We have a valley here. So if I were to break off this interval, that would be a valley. And then if we were to break off this interval, this would also be a valley. So we actually have two different numbers or locations where we have a relative or local minima. And then we'll have two values for our minima. So let's start by looking at this one right here. So first thing we want to do is identify at what number does that local minimum occur. Well, you can see it falls about halfway between -2 and -1. So we're going to say that it occurs at -1.5. And then again, we see over here that it occurs at 4. So this local minimum would occur at 4. So at what numbers does F have a local minimum? At -1.5 and at 4. And then what are those local minimum? Well, remember that that is determined by the y value. So here, the y value would be -4. So we would have a local minimum of -4 at -1.5. And then here, the y value is -1. So we would have a local minimum of -1 at 4.